Dry ice is a very popular material for demonstrations in chemistry. Who doesn't love working with dry ice? It's a unique material. Its properties are unique. If you add it to water, it foams and bubbles and so on. What we're going to do here is combine the properties of dry ice with an acid-base indicator to talk about the acidic properties of carbon dioxide dissolved in water. We're going to call this the dry ice color show. And I'm simply going to start by adding water to each of my beakers here. And the exact amount is not important. This is distilled water. I'm going to add about 400 milliliters to each. And I think I may need a little bit at the end. But this is the cooking show, so we've got here a little bit more than we need. And I've got some extra distilled water here. I do want to make them about equal. So I've got about 400 milliliters of water in each. What I'm going to do next then is add different indicators, acid-base indicators, to them. And so in the first one here, I have brome cresol green. And I just want to add enough to get a nice, deep, hopefully blue color there. I'm going to get my stirring rods here for a moment. And I want to get a nice deep blue color from the brome cresol green. Brome cresol green is blue in base solution when the pH is greater than about 5.4. So all that we really know at this point about that is that the pH is greater than 5.4. And I have a yellow solution there, which is universal indicator. Universal indicator is a different color at each pH value. At a color of yellow, that corresponds to a pH of about 6 for universal indicator. I'm going to add a little bit more there just so that we have some nice, deep, rich red colors. I'm adding phenol red to the fourth beaker here. Phenol red is red in basic solution and it's yellow in acid solution. Between 6.8 and 8.4 is its color change. And so if it's yellow, that means the pH is less than 6.8. So we had greater than 5.4, about 6, greater than 6.8. So we're kind of zooming in on this. What I want to do is get, this was less than 6.8. This is methyl red. Methyl red goes from red in acid solution to blue in basic solution, and I'm going to have to redo some of these. See if I have some paper towels here. I don't seem to have any paper towels, but I can stir, that's okay. I'm going to stir with my Burrell pipettes. Then I've got bromethymol blue. And that is blue in basic solution. What I want to do is make sure that I have the basic color of each one and that I have a nice deep color. And actually this one is green, a greenish blue, which means it's sort of in the intermediate range for that. The methyl red, that is the basic color of it. The phenol red, this is the transition color. So those that are not in their basic color, I'm going to add just a drop, literally a drop of ammonia. And that should be enough to give me the red color there, which is the basic color. I'm going to go with just a drop here of base to give that hopefully a nice yellow color, which is again the basic color there. And these are just aqueous solutions. And on this one, the universal indicator, I'm going to go ahead and add a drop, literally one drop of ammonia. And that gives me the basic color there. And actually on that one, I'm going to add just a little bit more indicator. And sometimes, if a little is good, more is better. And what that does is it just allows you to see a deeper color there. Okay, that's good enough there. I'm not going to need those again, so I'm going to take those out of there, add a bit more there. Okay, so what we want to see are the color changes that occur when we add dry ice. So the first thing that I'm going to do, because if we're going to see a color change, we need to know what the initial color is. So I'm going to pour a little bit of the initial color into the beaker in front of it, or to the side of it, so that we'll be able to see the original color and the color change. Okay, so this is just basically to give us a control set or a reference set of beakers. And again, we made sure that we have the basic color for all of these. And so that means that when we add CO2, when CO2 dissolves in water, it produces carbonic acid, H2CO3, and that dissociates, and it's an acidic solution. So we should see for each of these the color change to the acid color. And I've put on just a glove here to allow me to handle the dry ice. And I'm going to add just a little nugget of dry ice to each one. That's a little bit of a large nugget. And again, what we're going to do is see what the CO2, the carbon dioxide, does when it's added to it. And we're hopefully going to see a color change there as well. We can see there a color change has occurred. We've got a lot there, but that's okay. Bubble, bubble, toil and trouble. Like I said, everybody likes working with dry ice. The smoke that you see is actually the carbon dioxide or the water vapor that freezes due to the fact that it's so cold. The temperature of that dry ice is about minus 77 degrees Celsius. And so when that's added, you start getting carbon dioxide and water vapor that you see. And so even though it looks like it's boiling, it's really not boiling, it's bubbling due to the CO2 that comes off. And in each of these cases, we did see a color change from the basic color. And in this case, we had brome cresol green, that was blue in base. The acid color is yellow. We had universal indicator, that was a bluish purple color in base. In acid solution, it's a red-orange color. Phenol red was red or a reddish violet in a basic solution. It's yellow in acidic solution. We had here methyl red, that was yellow in base, red in acid. And finally, we had brome thymol blue, which was green. That's pretty much a neutral to basic color, and that turns yellow in acid. So again, this is a great demonstration. You see, you can do this on Halloween. You can get a cauldron-like effect from the smoke that's pouring out of the beaker. The CO2 is basically subliming and then reacting with the water. It gets very cold. So if you feel that, if you measured the temperature, it would be very cold. And you get bubble, bubble, toil and trouble in the chemistry classroom. Let's just go to the board as we're watching those, but we can write the reaction for CO2 solid, which is the dry ice. That sublimes. Sublimation is the conversion of a solid directly to a gas. So that's the sublimation reaction. The second reaction then is CO2 gas with water to give what we called carbonic acid, which is H2CO3. And finally, we can see the acidic color of all of those, and that's due to the acid-base reaction of H2CO3 plus water to give H plus and bicarbonate ion, which is HCO3 minus. So a lot of chemistry, a lot of very colorful chemistry, a lot of effervescent chemistry. Dry ice color show is just a fun demonstration to do to teach acid-base reactions, sublimation, properties of CO2, and so on.